Okay, students, so last example, I wanted to show you one more that was not centered at 0. So this power series is centered at x equal to -2. And an is n divided by 3 to the n plus 1. So as you've seen in the last couple examples, we would do the ratio test to determine the radius of convergence. And so here you have your n plus 1 term divided by your nth term, and here we already have the reciprocal. And so when you put both of them together and multiply and simplify, you get this expression right here. And I can factor out all the non-n factors and put it in front of my limit and keep the absolute value sign around it because I do have a variable x. And then I can continue taking the limit as n goes to infinity of the n plus 1 divided by n, that factor that was left behind, because we are doing the limit as our variable n goes to infinity. So that has to stay within the limit. And so we know that that limit goes to 1. And so then we have this absolute value. And in order for us to determine our radius of convergence, we set that to be less than 1. And then we want to get just the linear factor x without the divided by 3. So if you multiply out the 3, you'll get absolute value of x plus 2. And so your radius of convergence is r equal to 3. So now we want to determine the final interval of convergence. So we know that this is centered at x equal to -2. And so when you work out this absolute value problem here, you will get our possible interval of convergence to be -5 to 1. And so now we want to test out x equal to -5. And so we substitute -5 in for x. And when that's simplified, we get -3 to the n power. And so now this is base 3 to the n plus 1. So we will save 3 to the first over here, and we'll take 3 to the n and 3 to the -1, and we'll reduce it down to -3 to the n divided by 3 to the n, and we'll reduce it down to -1 to the n. And so now if we attempt the alternating series test, we will take the n divided by 3 and take the limit as it goes to infinity and see if it goes to 0. And it doesn't equal 0. It actually goes off to infinity, which then that would essentially our nth term test for divergence. And since that does not go to 0 and it goes off to infinity, or in other words doesn't exist, then we know that it diverges. And so at x equal to -5, it diverges. And then we do the same thing for x equal to 1. And when we substitute 1 in for the expression, we get 3 to the n divided by 3 to the n plus 1 times n. And when you reduce that, it goes to n over 3. And then again, you could do the nth term test for divergence, because you can easily see that as you take this to infinity, as n goes to infinity, it would go off to infinity as well. So the interval of convergence is -5 to 1, not including the endpoints. And that's it. Thank you.